Hey, friends, this is your host, Geoffrey Woo, on the Health via Modern Nutrition podcast, HVMN. Excited to speak with you all today, and I'm joined by my regular co host, Dr. Latt Mansor, our research lead at HVMN.
Yeah, nice to see you again. Jeff, haven't seen you in a whole week, so what have you been up to?
I've actually been a little bit off the grid. I was in the backcountry of Arizona, rucking around, learning survival skills, bushcraft. So if you want to bug out and figure out how to survive in the wilderness for a few days, I can maybe eke you out for 24, 48 hours. And any longer, I'll probably need to, do some more research and endurance exercise myself. But it was good to unplug for a little bit. And I know it's been big week for you moving around in San Francisco. How have you been?
I'm good. I've been doing my own survival urban style, moving from one place to another, one little studio to another little studio. Also marks the 1 year anniversary of me being with HVMN and me moving here to San Francisco, United States, August last year. So I think it marks a really great beginning of the second year. So looking forward to it.
100%. I felt like I've known you forever. I've done a lot of incredible work on the research program with HVMN. So, really a pleasure to see you operate, see you grow, see you step up as a leader in the area of ketosis. So, excited to see what the next year brings for the two of us and for HVMN, as well as the community of keto and fasting and all things metabolism. I just know that last week, I believe, we had a big Netflix special drop,
Yep.
docu-series called Unwell. You might have seen me talk about fasting, and you might have seen me do a lot of pull-ups and muscle-ups. I know that Latt made some cameos as well as a few other team members on the team.
Yep.
So it's continued to snowball and gain interest and momentum. So excited to be in an interest area that so many people are excited about. What I wanted to talk about for this episode of the podcast is taking a step back and really thinking about the state of the art of ketone esters. Obviously, ketosis, exogenous ketones, ketone esters are an important part of what we talk about, but we haven't really had a big, massive state of the art conversation. We've talked about specific research papers, specific use cases, and it's about time we step back and say, hey, probably the last time we talked about ketone esters as a state of the art was probably a year or two ago. The science and the momentum and the practice and the protocols and the use of ketone esters and exogenous ketones have evolved a lot since even a year ago. Let's talk and have an overview today. So for this episode of the HVM podcast, we're doing a 2020 August snapshot on the state of the art of exogenous ketones, especially ketone esters. Before we dive specifically into ketone esters, I think it's always worthwhile to make sure that we have the terms and definitions dialed in. So, one important thing is to define ketosis as a distinct and separate concept from ketogenesis and talk about exogenous ketosis versus endogenous ketosis. So, can you help define what ketosis is and what ketogenesis is?
So, by definition, ketosis is when your body ketone levels is zero point 0.5 millimolar and above. So that's in the state of ketosis, where you have achieved that level of ketone bodies in your blood. And then if you're talking about endogenous and exogenous ketones, now that vast difference there is whether you are taking in a form of ketones, be it ketone ester, diester, ketone salts, or whatnot. So exogenous coming in from externally versus endogenous ketones, meaning you're producing the ketones internally, and that's usually being achieved via either intermittent fasting or ketogenic diet. Those two are the generally more common way to create ketotic state, where you elevate your own ketone levels via via ketogenesis in the liver, and that increases that ketone body levels in the blood.
Yeah, 100%. And before the entrance of exogenous ketones, ketogenesis and ketosis are always, those two concepts are always conflated. Meaning that because there is no such thing as exogenous ketones as a technology, as a food, but essentially being in ketosis essentially assumes that you're producing your own endogenous ketones through ketogenesis. And now, as this technology of exogenous ketones have come into the market over the last 10, 15, 20 years from a research perspective, and then as ketone salts over the last 5 years or so, and then as ketone esters in the last couple of years, now we can really bifurcate and be specific about ketosis, ketogenesis, exogenous, endogenous. So that's absolutely right. And I think that zero point 0.5 millimole threshold is, I would say, fairly arbitrary. I mean, just some kind of definition that someone defines zero point 0.5. I think the more interesting question to me is what is a threshold where you see the metabolic benefit or the signaling benefit of ketone bodies? That's a much more precise way to define ketosis. And maybe that's actually something that I think is emerging at the state of the art. What is that threshold of ketone bodies that need to be present in the blood to see either metabolic substrate benefit, meaning that this is a fuel that the mitochondria are actively oxidizing, or is there a signaling threshold where at zero point 0.3 millimole BHB you don't really see much of a histone signaling effect or FOXO3 signaling effect, or some of the downstream pathways relating to mTOR, AMPK, the energy sensing mechanisms. What is that threshold from 0.1, 0.2, 0.3, 0.5, 1.0 that really you see a step function in that signaling effect?
But the problem I have though is if we define it, but that's a very interesting definition, by the way, Jeff. And I agree that we need to determine that, identify that, and further sort of do research on what is the threshold and how much it affects our bodies. But the problem I have with going through that approach is that what if that threshold varies between cases? Certain therapeutic metabolic changes will need a higher level of ketone bodies, whereas other type of conditions may require just a very low ketone levels. So then that means we are having different definitions of ketosis. So I think that's why they came up with a standardized zero point 0.5 millimolar ketone.
Yeah, I think that's a fair. I don't think we're disagreeing, but
No,
I'm
no,
just
no, we're
saying
not.
that yeah, I don't think we're disagreeing. I'm saying that zero point 0.5 is not a very precise definition
No, it's
either.
not. I
It's
agree.
fairly arbitrary, right? It's like you need to be in ketosis for neurological conditions versus athletic performance. Zero point 0.5 is very, very different for cardiovascular benefit, for neurological benefit, from sport benefit, right? Like even that zero point 0.5 threshold is, I think, as you would agree with me, is completely wrong in terms of sport benefit. It's going to be
Yeah,
too low
yeah, yeah.
for for the applications. So to me, it's more we need to get more precise,
Hmm.
and science is all about finding more and more precision.
Hmm.
And if I were to start making hypothesis generation, there will be more precision on levels of BHB that implicate certain kind of metabolic benefit or states as you're suggesting, and I think that will be personalized to your genetics, to your use cases, 100%.
Hmm.
Activating longevity pathways for me might be zero point 0.7 and for you might be 1.1. And I think that is the future of medicine in general. There will be personalized impact for all these metabolic markers or biomarkers. Again, like you can think about it from a glucose perspective. Maybe some people do better and are actually not diabetic at 105 milligrams per deciliter glucose. But the general rule of thumb is over 100 is considered pre-diabetic in a fasted state.
That's right.
So I think even then, these are like just to step back and and talk about medicine as a whole. Medicine is really done on a population scale,
Hmm. Yeah,
and that population scale is oftentimes not the same ethnicity, race, gender, social class, economic class as me, Geoffrey Woo, or you, Dr. Latt Mansor, or our listener, who at the end of the day, that's the model, that's the experiment you care about. Like I don't care what Michael Jordan uh, needs for his optimal performance. I care about what I need to be for my optimal performance. And that is, I think, the future. We're all getting there through quantified self, biohacking, getting our metrics so we can fine tune ourselves. So I think the same thing's going to happen with this notion of ketosis. It will be personalized to our specific genetics and as well as our applications.
Yep, 100% agree. The inter-individual and intra-individual variability definitely plays a very big role in metabolism. And in my area of research in metabolism and physiology, we have seen even, from animals to human models that metabolism varies quite largely between, different states, different genetics, and also different environmental factors. Different people in different countries, different weathers would behave differently. So personalized medicine is definitely the future that I'm looking forward to. As you said, like I care more about how certain nutrition and certain supplements would affect me personally versus it affects the whole population. Of course, we are interested in that too in terms of understanding the mechanisms of actions, but ultimately, how do I make sure that I get the most benefit out of a certain supplement?
100%. So now that we've defined ketosis, and I would say a much more precise and I would say just more innovative way, let's talk about exogenous ketones and just get a snapshot here of the interesting use cases, hypotheses, and ideas that we've come across in the last couple of years that is at the bleeding edge of what's known. I think given our position as part of the HVMN community, we're working with the very best athletes, we're working with the very best academics, we're working with the very best folks in the military across the board, and we just get to collect and understand all the different ways people are using, experimenting, and getting data. So I think we have a very unique vantage point that's different from just an academic lens, different from just a brand lens. I think we get this, and different from just a sports physiologist or a sports nutrition coach lens, and different from just the athlete's lens. I think we get to see and collate all of that, which puts us at a pretty unique vantage point in terms of what works at the professional level and what is shown in academia and what has been maybe potentially working at the top level of sport and performance, but not yet necessarily shown in academic studies. And then I think just from the anecdotal side of house with the community, I think there's also so much interesting little anecdotes or nuggets of information that might imply or generate hypotheses for how one can use ketones or research ketone esters in the future. So we'll explore all of that and we'll caveat what is the evidence level for said observation, whether that's anecdotal, whether that's been backed by an RCT, or that's something that just we're hypothesizing and speculating on. So this will be a fun one, a little bit off the wall, and hope we spark some insight into how we can continue to explore and experiment here.
Yeah.
Where do we want to start? I would say that let's just start from a performance perspective.
Okay.
Ergogenic effect for acute acute pre-exercise use cases. How would you summarize there? I know we've talked a bunch about this. What is the most concise way you would summarize? And I'll give you, we can maybe riff on it, and I'll give you my specific definition.
Sure. Okay. Well, I think I've got to start. Let's start with Cox's paper in 2016 as far as the ergogenic effect goes. So when the Cox's group published the paper, they saw an increase of 2% enhancement in performance after pre-fatiguing the athletes. They went through time trial and they saw that 2% improvement by giving them glucose and ketone esters before the exercise and topped up during the exercise. Later on, then there are a couple of other studies that showed no difference, but the protocol that they used were a bit different to Cox's paper because Cox's paper had fasted participants, whereas these other studies have got their participants have a normal meal before exercise, and they saw no difference there. So there's conflicting results so far as ergogenic pre-exercise ketone ester supplementation goes. So that's as far as we know. I think people are still trying to figure out the best protocol. And only a month ago, and we talked about this as well on the podcast, the most recent paper from Haspel's group, which added bicarbonate and ketone ester in a fed state, actually saw a 5% increase in performance in the time trial after pre-fatigue sessions. So that's the latest protocol that we know is adding glucose, ketone ester, and bicarbonate to offset the ketoacidosis caused by ketone ester, and neutralizing that pH drop to improve and optimize the mechanism of actions of enzymes, proteins, and metabolism in general to make sure that your body is in the optimal state.
Yep. So I think that last part encapsulates my current August 2020 recommendation of how to use ketones acutely before exercise. Stack ketones with carbs and bicarbonate. And it sounds like through the different protocols, you can tease out acidosis versus fasted versus fed. And in the general application use case, if you're trying to win your marathon, win your Ironman, go kick down doors, and if you're a warrior, uh, do bicarbonate, ketones, glucose, and then likely top off ketones during the middle to have an added boost of having ketones in the system. If you start detracting and taking away either glucose or bicarbonate, it's not negative, right? We're not saying like decrements of performance, but you're just not getting the full benefit of having all of the synergies across the different supplements one can be stacking together. So I imagine, and I know that we've been in contact with Professor Hesbel, the KU Levon group, which I know is doing just great work out there. And I know they just have so many different like experiments as well as unpublished data that is just going to be coming out. So we'll be following that very, very closely to keep everyone up to speed on the very, very latest protocols to optimize uses of ketone esters, exogenous ketones as part of this podcast. So stay tuned as we update what is known in research. Now, moving on to recovery, I think recovery is going to be known as the dominant use cases of exogenous ketones moving forward. I think the data is and the mechanisms are so much more clear, and the effect sizes are so much bigger on the recovery side of house. Again, another Peter Hesbel, K. Levon study showed that in an overtraining, overreaching protocol of 2 to 3 workouts a day for over 3 weeks, ketone ester group was at the end was doing 15% more work volume compared to control, which is a massive difference in terms of work output. And the mechanisms would make a lot of sense to me in terms of stacking ketones with protein with carbohydrates, actually increasing mTOR activation. So you're seeing quicker protein resynthesis and quicker glycogen repletion. I think those are interesting and very reasonable mechanisms. And it makes sense from a lot of the observations I've seen from now moving a little bit to what I've seen when people are using it for weight cutting, the anti-catabolic effect of ketones, which again makes sense from an evolutionary perspective, where when you are fasting, that's when ketones are up. And when your ketones are up, you want to be protecting and sparing your protein and your muscle. So that seems like a very tight, cohesive story from a mechanistic perspective, as well as an evolutionary argument of why introducing ketones from a recovery perspective is so beneficial. Do you have any other color or you want to add anything to the recovery side?
Yeah. I want to really bring forth some nuance between these studies that you just mentioned as well. Yes, they have seen that ketone esters taken for recovery did increase glycogen synthesis by up to 50%. And yes, they did see that taking ketone ester as recovery for 3 weeks increased performance in the long run, as well as really activating mTOR downstream targets. However, they have been contradicting results with regards to glycogen, because one study showed the improved in glycogen resynthesis, while another actually, while they showed the activation of mTOR, they did not see the increase in glycogen resynthesis. Now, do note that when I say there is no increase in resynthesis, does not mean that it slows down. It just means that the glycogen rate of resynthesis is the same as control, meaning that there's no effect of ketone ester there. So what I hypothesize, looking at the protocols, just purely by looking at the protocols of these studies, is that the study Holtzworth et al. They saw the increase in glycogen resynthesis, and they gave glucose and ketones as post-recovery nutrition. Whereas Van Dorn and Poff, they gave the athletes protein, glucose, and ketone ester as post-recovery nutrition. So notice that the difference is the addition of protein into the mix. And my hypothesis is that adding leucine, especially leucine containing protein, into the post recovery mix, it actually activates leucine mediated mTOR activation, and that overrides the increase in glycogen resynthesis and glucose metabolism, because the increase of mTOR does inhibit to a certain extent glucose metabolism.
Interesting. I was thinking that you were going to go more on the delivery of glucose because Holdsworth delivered glucose through an IV, which is super physiologically high amounts of glucose,
Correct. That they use glycemic gland.
which would have been a little bit of a cheat, right? It's like you're injecting glucose into your blood
Infusing, yeah.
versus like how much you can consume. So I 100% agree with you. I should have been a little bit more nuanced there, but my sense is that exactly as you're describing, the mTOR activation for increasing muscle resynthesis, I think that's a dominant and most interesting effect that.
Yeah. And glycogen, as they have looked before for many years now, the resynthesis after exercise takes place 12 to 24 hours after, and if given ample of carbohydrate, you shouldn't have any problem resynthesizing it. So if I have to take a note from Holdsworth's paper, yes, they're using IV and glycemic clamp and very high amount of glucose. But if it holds true with oral glucose as well, as like if you take high glucose, high ketone ester orally after exercise, if that holds true with the result meaning that they do increase glycogen synthesis, I think that would be best for situations where you have very short rest period and you need to, let's say you are going on an ultra marathon, you have rest period of like few hours, and then you have to keep going again. That could be good to be used to replenish their glycogen stores. But again, nothing has been done in that situation or really proven, especially orally taken together, glucose and ketone ester. So that is pure speculation here.
And relating to recovery is what I wanted to explore more about, which is like this application of weight cutting.
Yeah.
So we work with a lot of athletes who participate in sports with weight classes. And you can think powerlifting, MMA, boxing. Um, there's weight classes. You got to weigh in at 205, 185, 155, 125. And oftentimes these athletes basically try to be as big as possible and right before the fight cut as much weight as possible and then weigh in and then rehydrate, refeed and blow back up. So oftentimes as you know, as we work with fighters, they might weigh in at 155, but on fight night they're at 170, 175. So they're literally ballooning down and gaining 20 pounds of extra weight after they weigh in, which is obscene. I mean, think about it, going and gaining 20 pounds of mass in a day. Um, so obviously, there's a lot of protocol and research on how to best do this
Hmm.
because it's like saying, "Hey, go starve yourself before you have like the most important fight of your life or your
Right.
most important competition. How could you really perform at your peak?" So a lot of exploration within the process of weight cutting. And I think exogenous ketones, ketone esters are a very interesting tool here because of what we learned about the mechanisms of protein sparing, anti-catabolic effects of ketones. So I don't believe there's been a lot of actual academic research in this space, but what I can say is that while working with athletes and top level coaches and athletes, they're seeing good results from using ketone esters as a way to support their weight cut. And I see it in two ways, which is, or two mechanisms that make sense to me, which is one, the control of ghrelin. Ketones were shown to reduce ghrelin, which is an appetite hormone. So that makes people less hungry as they're trying to lose weight. And then then the second part is the anti-catabolic effect, where ketones signal a sparing of muscle protein. So I think when you have 1 plus 2 together, it makes a lot of sense. Where if you're having a fixed calorie count, it makes sense to introduce at least some portion of those calories to be ketones to maximize strength and power and endurance to weight ratio. Anything that you would add in terms of adding color or nuance?
No, I think that's a very perfect way of explaining the mechanisms as well as the current knowledge that we know based on the publications and the research that we have seen. Certainly, ghrelin and the muscle preservation. Now, one interesting point for me to point out is going back to what we're talking about recovery. Poff's paper with Haspel's group, when they use ketone ester as recovery strategy, what they have seen over 3 weeks is that instead of losing weight, these athletes, the 15% improvement seen in these athletes with ketone ester, they actually saw an increase in increase in calorie consumption, which is also matched by increase in energy expenditure. So that to me is quite interesting because that means they actually ate more, but also in turn they burn more. So it's interesting to dissect in terms of what sort of things they are actually doing that's different between this ghrelin publication, like a group of people, by suppressing ghrelin you're suppressing appetite, and then people using it for weight cutting, and then versus athletes who are using it for recovery, and how do they actually perceive hunger. And they did go through a bunch of questionnaires asking like the desire to eat or like the perception of hunger. It does affect it to a certain extent for sure.
Yeah. I mean, my speculation is that at rest, the ketone esters boost the ghrelin, but when you're in an overreaching situation, which is that you're working out so friggin' hard
Hmm.
that you're getting sore, my hypothesis is that ketones as an anti-catabolic agent is making you feel less like the rate of perceived exertion is lower, so you feel less crappy, so you eat more. That would be my hypothesis. Explore like basically an impact on the central nervous system, your brain.
Okay, that's a fair point.
So interesting area to explore. Which is actually a good segue to even let's talk about the brain from an athletic perspective. From a powerlifting perspective, we've again heard a lot of anecdotes at the very, very elite level that people feel like they can lift more weights, Olympic powerlifting weights with ketones in their system, which doesn't necessarily have a clear mechanism from a energy system perspective, right? Because when you do a motion that is at a second long basically, and you're sprinting that whole second, that's entirely phosphocreatine system. You're not even really oxidizing. You're not even using glycolysis. It's just like the instant burst of your phosphocreatine system. So it doesn't make sense from a metabolic substrate perspective why ketones would do anything. So to me, this generates a hypothesis around, again, CNS, your brain. Do you somehow feel better, feel more alert, feel more hyped up? Is it like you feel less tired? To like feel like you're a superhuman and just lift and get a PR? There's something there that's happening.
And that's interesting because in some studies where the athletes were undergoing endurance exercise, so opposite to what you just said, the explosive resistance exercise, they actually went through endurance exercise. And the ketone ester group actually had higher rate of perceived exertion. So they actually found that they it's harder for them to work out during that first hour or so. Now the scientists, they did theorize that it could be the buildup of acid, the acidosis in the body that
This was the Heswell paper, right? Which was balanced out with the bicarbonate.
correct. So that's the interesting part. Whereas with you, what you just said, we would assume that ketone would upregulate. If you take ketone for a long time or you're on a ketogenic diet, you're fat adapted, you would upregulate the fatty acid metabolism and downregulate glucose metabolism, and that may affect to some certain extent short bursts of exercises or whatnot. But that's the interesting point.
Yeah, I mean, I think it's just like very different interplays, right? Because I think when you're doing for the endurance, what you're talking about with like increased RPE, rate of preserved exertion, I think that's from the acidosis,
Hmm.
right? Which is eliminated when you add bicarbonate, which is a buffer.
Yeah.
But because when you're just like popping ketones right before your 1 second power lift, acidosis probably doesn't matter because it's like such a short burst that the cognitive effect dominates. So I think again, this opens up that can of worms where every context is so specific and there's so many different variables to dial in for to make these incremental changes from gold medal to bronze medal to not even making it to the Olympics. So to me, there's something around the CNS that is just like not super observed yet. Where that's somehow we know that it impacts GABA. We know that it impacts your neurotransmitter chemistry. That is maybe the extent. I mean, I think from an application or more behavioral perspective, at least in the in animal models, we see anxiolytic impact of ketones in the system. So mice are a little bit more exploratory, less scared, and I can see that's been reflected in anecdotal study or reports from. I know that Rhonda Patrick was on Joe Rogan's podcast talking about that she uses it before big speeches and big talks because it makes her feel a little bit more clear and fluid. So again, that just recapitulates to me that there's something happening in the brain when one is adding ketones, and that might explain why you're seeing benefit for powerlifting as well as before talks. And I guess another just more specific exploration area is that cognitive impact from the BHB itself, or is it from within the ketone ester? One half of the ketone ester is butanediol, which is a form of an alcohol. It's not like drinking alcohol like ethanol. It's butanediol. And I just wonder, is that the CNS effect coming from the butanediol or the beta hydroxybutyrate itself? And that, as far as I know, is an open question.
Yeah, I do not have answer to that as well. It would be exciting to see what comes out of that research.
Yeah, and I know that we're supporting the NIH looking at neurological conditions as well. So, um, and I think that was one of the most dominant use cases that I would say folks like Dr. Veach and Dr. Mary Newport were most excited about the applications of ketones for cognitive impairment. And again, Alzheimer's is one of the big rising diseases that's killing or debilitating so many of our elderly friends, community members. So, not even from a performance perspective, but from a therapeutic perspective, that's a very, very exciting area. Although the mechanisms are probably very, very different.
Yeah, I was going to say they're very different. And it'll be interesting to compare and contrast the different mechanisms between therapeutic, which is more chronic use, versus, as you said earlier, the acute use in performance, to see if it actually goes through the same pathway or same metabolic cascades that affect both conditions.
So, the mechanisms, to my understanding of how this is useful for neurological conditions, relate to two different impacts. One is a potential dysregulation of pyruvate dehydrogenase in the brain in neurons. PDH is required to convert glucose into pyruvate, which is then entered into the Krebs cycle of the mitochondria. It seems like in Alzheimer's brains, you see less PDH activity, and that might be caused by insulin resistance of the brain or some sort of glucose problem in the brain. The great thing about ketones, it crosses the blood-brain barrier. It doesn't require PDH to enter the mitochondria into the cell, so you have a very clean alternate fuel substrate that burns. So you're allowing the energy of an Alzheimer's brain to remain high. So if you actually look at brain scans of an Alzheimer's patient versus a normal patient, the normal brain is just so much more activity and energy going around, which makes a lot of sense. You're more alert, you're more alive, you're more there. And I also know that for Parkinson's, for other diseases, they're looking at the implications of NADPH, which is one of the coenzymes that is a part of the Krebs cycle, and ketosis pushes the NAD/pH ratio in a more optimal way. Um, so probably a little bit too technical for the purpose of a general overview of what we're talking about here, but there's a lot of interesting discussion with all of longevity and a lot of these chronic diseases that relate to the coenzymes within the Krebs cycle. And I think we've heard a lot about NAD precursors, NA nicotinamide riboside NR, NMN, and those are really things that expand the pool of what's available of NAD starting materials. But I would say that Veach has always argued that it's not necessarily just how much starting substrate it is, if it's just gated by the fact that you need ketosis to shift the ratios in the right amount of way, right? It's if you have 10 seamstresses or people that are making clothes, and if you just keep dumping silk or thread, but you're only capped by 10 people that can actually use a thread, just by dumping thread doesn't make you have more of the end cloth.
Hmm.
So actually changing metabolic state through ketosis seems to be a very important gating factor to unlock some of the benefit of all these NAD precursors and all that good stuff.
Yeah, and there is a study that used our ketone ester that showed increase in brain network stability in young adults. So they managed to sort of scan these adults for risk of cognitive impairment for later on when they age, and they could identify as early as like at the age of I think 49. And by taking ketone ester, they actually saw an increase in stability between the brain regions, and all the networks actually communicate much better after ketone. Actually, they saw the same benefits with both endogenous and exogenous ketones because they try ketogenic diet as well as exogenous ketone esters.
Yeah, and I think what's also important in terms of brain stability is sleep. I think we're all chronically under, probably not sleeping well, whether through stress or just ambient environmental factors. But I think, again, one of the coolest anecdotal reports, and I have, again, no one has studied this formally, so it, uh, ambitious PhD students look into this. We're seeing a lot of anecdotal reports where, even 5-10 grams of ketone ester seem to increase deep sleep scores as measured by popular consumer wearable devices like Oura rings or Whoop straps. So I don't know. I mean, again, like, why? I would just defer to, probably something to GABA, adenosine, all those neurotransmitter systems that we know get impacted by the presence of ketones, ketosis. But specifically, why? Is it an anxiolytic effect where you're just a little bit less stressed out, you're a little bit more calm? Is it something that's, as you're talking about brain stability, your neurons are firing a little bit more cleanly, so you can sleep better? Any other speculations or hypotheses you might have on why we're seeing improved sleep scores?
I don't actually. I don't. I mean, yeah, I don't have any personal speculations myself. I do, hope that soon, in the near future, we have some neuroscientists or neurologists come and tell us like what exactly is the ketone ester doing to our brain that help us sleep, or if it does help us sleep. Because we also have seen some anecdotal examples that people after taking ketone ester they get into this hyperactive state where they can't sleep. So what makes them so different? People who sleep better with ketone ester versus people who get hyperactive after ketone ester.
Yeah, I think that's a good point. I think it's a very, very fair point. Yeah, and I think that's a good anecdote to bring up and say, like, hey, some people definitely feel like almost amped up like a caffeine from ketone esters. Any other general use cases that you find interesting? I would say that TBI prophylaxis is another interesting research area. Again, there's been good animal data suggesting that presence of ketones uh, is neuroprotective. Longevity is an interesting application research area. My personal hypothesis and belief is that the reason why calorie restriction works is because it's mediated through ketones, beta hydroxybutyrate. So you can essentially mimic calorie restriction through a ketogenic diet or through exogenous ketones. There, I would say the exogenous ketone part is maybe a little bit impacted by what else you're consuming. I don't know if you're going to see the same benefit if you're eating a lot of sugar on top of ketogenic and ketones at the same time. That might be great for performance, but maybe not so good for longevity. But my main point is that ketones themselves, whether expressed endogenously or through an exogenous product, should dominate or be the majority mechanism that drives longevity benefits from calorie restriction. At least that's my hypothesis. Anything you want to add in terms of those two areas of applications?
No, I think that's a very fair point. What I would love to see though is that the difference in endogenous and exogenous ketones in mediating that calorie restriction. Do you know what I mean? Like we know that taking ketone ester does inhibit ghrelin or does have effects on ghrelin. Now, ketogenic diet, on the other hand, what people have seen is that because people consume more fat, and that itself make you feel more full. So that may or may not directly be associated with ghrelin per se, or ketones and ghrelin. So I want to see the discrepancies between those two, endogenous and exogenous ketones in mediating that appetite suppression or mediating that calorie restriction. I think those areas for me, just out of my curiosity as a scientist, as a person interested in biohacking, would be very thrilled to look into.
Cool. Yeah, I would say that maybe we now pivot towards combinations or stacks. I think with the emergence of Hezboll's bicarbonate introduction, like that to me
Mm-hmm.
is almost the gold standard of how you use ketones.
Yep.
You gotta buffer out potential downside of adding metabolic acidosis when you're having a huge bolus of ketones all at once.
Especially in the fed state.
Yeah, exactly. So what else is interesting in terms of combining? Well, I've heard of people using ketones as a part of a plant medicine ceremony. And I think that's kind of interesting from an anecdotal perspective because with a lot of plant medicine ceremonies, they often have people fast or purge before they do these very intense ceremonies of plant medicine, right? Um, so I wonder, was that purging to to like make sure you don't throw up and vomit in terms of just making sure you're fasting, which was probably the dominant reason why they have people fast and purge before they do these ceremonies. But I wonder if that understudied or under thought about mechanism is that you're having ketones in your system, and ketones plus plant medicine has a boosted impact for how the medicine affects them. So I've heard that people feel like as they're doing multiple day ceremonies, they get tired and lethargic, and they'll pop ketone ester, and they'll just like feel like it just like re-spark their brain up. So this might be more on the recreational side of stacking different compounds. We're not recommending anything that's not, or we're not recommending anything that's illegal here. This is just mainly anecdotal passing along of information. But that seems to be interesting, at least from an anecdotal perspective, of how the brain can be perceiving energy, or when you start combining multiple substances that are neuroactive, which is risky to say the very least, but potentially interesting to research to see if there's synergies.
Would you say though, is it the synergistic effect, or I mean, I don't know much about plant ceremonies, but if what you're saying is that they would throw up or they would be lethargic, wouldn't taking ketones, which is a form of calories, would then make them feel better just because there is an input of calories? So meaning to say, like, playing the devil's advocate, so would having 120 calories of glucose or fat work the same?
Yeah, I think I think you got a calorie match. Is it just the presence of calories, or is there something special with ketones themselves?
Yeah.
That I don't have that much to speculate other than we do know that ketones act on the brain in a pretty unique way.
Hmm.
So I think that's like exactly why we need to do more research here. So I think that's a good, again, like I think it's like this is why it's fun to have these conversations. Like here's some crazy hypothesis. Here's why that crazy hypothesis could be BS. and let's run the experiment to see who is right. Um, what else is interesting in terms of stacking? Speaking a little bit about TBIs, I know that there's been research around omega 3s and specific forms or derivatives of omega 3s, like specialized pro resolving mediators, SPMs, which have been shown to have some impact on TBIs. So I wonder if there's combinations of things like SPMs, lactate, ketones all together as some sort of combination synergistic TBI prophylactics elixir when people are going out into events or sports or activities that have high risks of concussions. That could be very, very interesting. And I know that some people are already using that for combat sports. Maybe not to the extent of having lactate, SPMs, and ketones all together. But if I were to give my best free advice, you get what you pay for. I would recommend exploring with some of these substrates that have been shown to be neuroprotective and combining to see if they are synergistic.
Yeah.
Another thing that is somewhat related to that is hyperbaric oxygen chambers. I know that having high oxygen is also, people use it for neurological conditions. And I know that there's been some community members who've been using ketone esters, stacking it with hyperbaric oxygen therapy and you know, feeling lit basically when you're doing those two together, which kind of makes sense, right? Because you're having high ketones and having high oxygen, and you're just oxidizing like the super efficient fuel really, really quickly. So no one's that's actually studied this formally, as far as I can tell, but that could be an interesting protocol before a competition. Ramp up ketones, and then sit in a hyperbaric oxygen chamber, which is like hyper compressed oxygen, for a couple hours, and see if you're just again on fire.
Go on an overdrive.
Yeah. So I think anything else that is interesting to at least highlight in this overview here.
No, I think we've covered most of the things that we think would be interesting. We covered performances, we covered the brain, both therapeutic and cognitive performance. We covered other usages that may not be published per se, but more of anecdotal, different stacks that people use just from our customers talking to us.
We haven't covered cardiovascular. Do you want to highlight a little bit of the overview there in terms of how ketones might impact cardiovascular health and outcomes?
Sure, sure. I mean, right now we know for a fact that there are a couple of research groups that are currently researching using ketone ester in cardiovascular disease, in heart failure especially, because what they hypothesize is that ketones may provide a more efficient energy source compared to the other substrates in the face of heart failure. And this was sort of recapitulated by Sato in the 95 paper, where they showed that ketones actually is more efficient per unit oxygen versus glucose. And if this is true, then when you go through a myocardial infarction or ischemia, you have lack of
AKA heart
yeah,
attack.
heart attack. You'll have lack of substrates going into your capillaries, going into your heart. You've got lack of oxygen going to, so you're going through hypoxia. If ketone ester one helps with hypoxia, which has been seen in animals, that could also increase the hypoxic adaptation of the heart. And secondly, if it's true that ketones is more energy efficient and delivering the optimized energy source while the heart is lacking glucose or fat going into the heart, it could provide another avenue in which the heart can still metabolize, create ATP, and continue pumping. A lot of cases, heart failure occurs after a heart attack is because even though the patient survived the heart attack, the tissues, parts of the tissues of the heart have been damaged because of the lack of oxygen, because of the lack of substrates, and they can't. The heart part of the heart cannot provide that energy, and the cells just die, and that damage is done. And because of that, further on down the road, it increases the risk of the heart not working properly, and then you get arrhythmias, which is irregular heartbeats and different dysregulation of heart rate, and that would eventually lead towards heart failure, where the heart just fails altogether. So providing a form of substrates that may mitigate that damage by giving the heart, that energy it needs, could potentially decrease the risk of developing heart failure.
Yeah, I think that's a pretty good deep dive into an area that you're an expert in. So that's, or like at least a cursory dive. I know we could probably have a full entire podcast just talking about cardiovascular, which we might want to do if there's interest from our listeners here. And maybe the last point that I'll leave it up to is, again, back to one of the first things we talked about, which is what is the level of threshold of ketones necessary to even have any of these impact areas? Because we're seeing great results from a ketogenic diet. So do you need exogenous ketones if you just have a ketogenic diet, maybe do some intermittent fasting? Maybe you don't need the super expensive ketone ester. You can have our MCT or our keto collagen or some of our other products are just going to be coming around the corner that boost your ketones mildly, because you don't need 3.0, you don't need 5.0 millimole ketones, because you're not trying to win the Tour de France. You just need to get from 0.5 to 1.0. And if those thresholds for some of these metabolic impacts for these use cases are that mild, which is hard, there's emerging evidence that you don't need that much ketones for a lot of things we're describing, right? It seems like the threshold for some of the metabolic impact, especially for cardiovascular, right? I think some of the research we've seen, you only need about 1.0 millimole. Is that correct? To see these impacts.
I think it's still, yeah, it is still unclear, but you certainly don't need, yeah, you don't need three for sure, but it is unclear as to, whether you need, is it one, is it point 0.1, point 0.5, is it 1.5? It's still unclear at the moment. But certainly, if we're looking at, say, for example, I'm just giving an example here, for diabetes, you certainly don't need all the way, up to three to see glycemic decrease, glycemic control in diabetic patients or in obese patients.
So that to me is what I'd like to encourage this community to research in the future. I'm calling academics, sports physiologists, professors, hobbyists to really narrow down the actual thresholds, because we don't necessarily need to just be ketone chasing. We don't necessarily need to just be like eating supplements and whatnot. We didn't actually need to know the threshold of ketones necessary for the role and impact and application that you're looking for, and cross that by your own personal genetics and your own personal use cases. So that is going to be the most impactful area of metabolic or ketosis research I see in the next couple of years, really understanding the thresholds required to see the benefit. So then you actually know, when is it appropriate to have food or high fat diet or intermittent fasting to get to what you want, and when it's appropriate to have more potent exogenous ketones, going from MCTs to ketone salts to ketone esters to, hey, let's infuse ourselves. Maybe like I want to have 8 millimole ketones all the time. And I just like have a ketone bag into my carotid arteries pumping me ketones, 24/7, right? Maybe that'll be a fun biohacking experiment. Me walking around with an IV bag with with ketones infused. Um, that would be fun. So we'll leave it at that. I think we've definitely surveyed the landscape, what I think are some of the most interesting, most exciting, most understood aspects of ketosis. And hopefully this asks more questions or opens up more questions than answers. I think that's part of why we wanted to do this, which is that I would say we're in the very, very early innings of fully understanding ketosis and metabolism in general. Again, I would say that, 15, 20 years ago, ketosis was thought of as a metabolic dysfunctional state. And now that's being rehabilitated. I think you're going to see now moving forward that might be a metabolically advantaged state that we actually want to be spending more time in. And it's cool that literally within my short lifetime, I've seen that change. I mean, just even in my time in this area of science, I've seen that change going from 6 years ago, where ketosis, when you Google it, the first result is ketoacidosis, to now, hey, ketogenic diet is like the most popular diet that people are searching all the time. So that's just even in my time being an active researcher, contributor, thinker of this space. So I can only imagine 6 more years down the line where we'll be at. And I'm sure you're seeing the same thing in your trajectory, in your career as well.
Yeah, definitely. I think what a lot of people don't realize is how fast this area is growing, because even though research can be slow sometimes. It takes years to find a molecule. It takes years to create something that works in certain therapeutic areas. But once the interest of a certain compound or certain area grows, the speed at which it just goes exponentially. And more people, more different groups around the world start using this molecule or start using this method or this diet to achieve something. It just all work together, and suddenly there's an explosion in the space, and we see all sort of knowledge being acquired, and a lot of like discoveries being like opened up to public. And I think that's the beauty of science, and a beauty of our job as being people who are more in touch in the current research in the area, and sharing it with the public and sharing it with everyone else.
Yeah, great. So we'll wrap it up here. And as always, ask either Lat or I questions anytime. Uh, this is like the main reason why we do this is we have so much knowledge that we want to be sharing, and it's honestly fun for both Lat and I. So thanks for staying and coming to the end of this episode. I know it went from pretty light to pretty technical and bouncing back and forth between like super nitty gritty metabolism to pretty interesting applications and pretty speculative combinations of plant medicine plus ketones. So this is a fun one. I hope that we'll do another state of the art update in 2021, and we'll have much more and hopefully answer some of the questions that we've brought up today. So as always, thank you for taking the time. Follow me at HVMN or at Geoffrey Woo across all social platforms. And until then, talk to you guys all very soon.
Thank you very much, everyone. See you guys soon.